Myself Rajendra S. Parai. My qualification is MSc Chemistry B.Ed and experience is of 28 years. Now, today we are going to discuss about the ionic equilibria under the heading of concepts and techniques. Now, in this case, we will discuss about hydrolysis of salts. Particularly the topic identification of salt. Here I write down definition of hydrolysis. Salt consists of cation and anion. Lysis means breaking or decomposition, and hydro means water. That means reaction in which cation or anion or both the ions of the salt react with ions of water to produce acidity, basicity, and sometimes even neutrality. To the solution. Now here hydrolysis of salt, it is the reverse of neutralization. This is because neutralization is the reaction in which acid react with base to give salt and water. Now here write down types of salt. Actually, salt consists of acids and bases. Now, acid may be strong or weak, base may be strong or weak. Depending upon this fact, the salts are further classified into 4 types. That is salt of strong acid, and strong base. Examples are NaCl, KCl and NaNO3 etc. Na2SO4 also. Second, salt of strong acid and weak base. Examples are NH4Cl, NH4NO3, then next ammonium sulfate, copper sulfate and FeCl3 etc. Then third, salt of weak acid and strong base. Now here examples are sodium acetate, comma KCl and Na2CO3 etc. Fourth, salt of weak acid and weak base. Example, ammonium acetate, ammonium cyanide, ammonium carbonate, and ammonium oxalate. Now let us consider the first salt. Salt of strong acid and strong base. That means here this salt do not undergo hydrolysis. That means here concentration of H plus ion is equal to concentration of OH minus ion, and aqueous solution of this salt is neutral. and here no relation are exist. Second, salt of strong acid and weak base. Here, which species is strong? Here, acid is strong. That means, here write down first, undergo hydrolysis. And here, solution of this salt is acidic. Here write down pH equal to 7. Solution of this salt is acidic. Why? Because here acid is strong and base is weak. As the solution is acidic, meaning is that here concentration of H plus ion is greater than concentration of OH minus ion, and pH is less than 7. Now here first relation is KH is equal to S square C. Second relation is KH is equal to KW. KW is same in all derivation. Now tell me the species or term which is present in the denominator. Here base is weak, so they take the dissociation constant of base in the denominator. Then third, pH equal to 1/2 pKw minus 1/2 pKb minus 1/2 log C. Then write down third salt. Salt of weak acid and strong base. Now this salt also undergo hydrolysis. Now in this case, what is the nature of salt? Aqueous solution of this salt. Let us tell me the species which is strong. Here base is strong, that means here the aqueous solution of this salt is basic, that is here concentration of OH minus ion is greater than concentration of H plus ion, and pH of this solution is greater than 7. Now here the relation between KH and H is KH is equal to S square C. Second, KH is equal to KW, and which species is present in the denominator? The dissociation constant of weak species. Here acid is weak, therefore write down here Ka. And finally write down pH is equal to half of pKw plus half of pKa plus half of log C. Now here write down 4 salt of weak acid and weak base. Now here write down undergo hydrolysis. But here nature of this solution depends upon the dissociation constant of acid and dissociation constant of base. If Ka is equal to Kb, then concentration of H plus ion is equal to concentration of OH minus ion, and the solution become neutral and pH is equal to 7. Second, if Ka is greater than Kb, that means concentration of H plus ion greater than concentration of OH minus ion, solution is acidic and pH less than 7. And if Kb is greater than Ka, then concentration of H plus ion is less than concentration of OH minus ion, solution is basic and pH is greater than 7. Now here write down the relation, that is KH is equal to S square. Here concentration term is not present. That means here H is equal to under root of KH. That is the degree of hydrolysis of salt of weak acid and weak base does not depend upon its concentration, meaning is that its dilution. Second relation, KH is equal to KW upon, both species are weak here, so the dissociation constant of both the species are present in the denominator. And finally write down pH is equal to half of pKw plus half of pKa minus half of pKb. Now, but most important question is that how will you identify the type of salt easily? In order to apply the concerning concept or concerning formulas, that is, here write down identification of salt. First let us consider sodium chloride. Here write down formula of sodium chloride, that is NaCl. Now separate here cations and anions, that is positive and that is negative. Now attach OH minus ions of water to the cation and H plus ions of water to the anion. That means this salt consists of HCl and NaOH. Now here HCl is strong acid and this NaOH is strong base. That means sodium chloride is a salt of strong acid and strong base, and apply the concerning term to this. Then next, ammonium chloride. Again write down the formula of ammonium chloride, that is NH4Cl Now separate this into cation and anion. Attach OH minus ion to the cation and H plus ion to the anion. It becomes HCl plus NH4OH. This is strong acid and this is weak base. That means ammonium chloride is a salt of strong acid and weak base. In a similar manner, third, sodium acetate, that is CH3COO-Na. Again separate cation and anion here. Attach OH minus ion to the cation and H plus ion to the anion. That means here write down CH3COOH plus NaOH. That is weak acid, and here write down strong base. Sodium acetate is a salt of weak acid and strong base. Fourth salt, ammonium cyanide. NH4Cl. Again separate into cation and anion. Attach OH minus ions of water to the cation and H plus ions of water to the anion. That means here write down HCN plus NH4OH, that is weak acid, and here weak base. That means ammonium cyanide is a salt of weak acid and weak base. In this way, you can identify the type of salt and apply the concerning term to that particular salt in order to solve the numericals. Now, this is regarding about the hydrolysis of salt and identification of salt, and remaining parts will be discussed in next lecture.